Have you ever wondered what a three-dimensional quaternion is? Or perhaps you've heard the term floating around in a physics class or on a science forum and found yourself scratching your head. Well, don't worry. Today we're going on a journey to unravel this concept and bring it down to earth, explaining it in the simplest terms possible. Imagine a world where 3 dimensions just aren't enough. That's the world of three-dimensional quaternions. Quaternions, in the simplest terms, are a kind of mathematical object that can be used to represent rotations in three-dimensional space. They extend the concept of complex numbers, which you might already know about, and take it one step further into the third dimension. So you can think of a quaternion as a 4-component vector, where one component represents a real number, and the other 3 represent imaginary numbers. But don't let the term imaginary fool you. These numbers are very real in the world of mathematics and physics, and they're integral to how we understand rotations and movements in 3 dimensions. Now you might ask, why do we need quaternions when we already have matrices to represent rotations? Well, while matrices are great, they do have their limitations. For one, they can sometimes lead to something called gimbal lock, which is a situation where 1 degree of freedom is lost due to the alignment of 2 rotation axes. Quaternions, on the other hand, do not suffer from this problem, making them a valuable tool in fields like computer graphics and robotics. Another advantage of quaternions is that they can be interpolated smoothly, which is a fancy way of saying that they can be used to create smooth transitional rotations. This makes them ideal for animations and simulations where a smooth transition from one rotation to another is needed. So, to sum up, a 3-dimensional quaternion is a mathematical object that extends the concept of complex numbers into the 3rd dimension. It consists of a real number and 3 imaginary numbers, and it can be used to represent rotations in 3-dimensional space. Unlike matrices, quaternions do not suffer from gimbal lock and can be interpolated smoothly, making them a valuable tool in various fields. In the world of physics and mathematics, quaternions are like the secret sauce that helps us understand and manipulate the world around us. So next time you see a stunning 3D animation or a sophisticated robot, remember that there's a good chance quaternions are working their magic behind the scenes. And there you have it. The world of 3-dimensional quaternions. Complex yet fascinating, abstract yet immensely practical. A world where the imaginary becomes real and rotations become a piece of cake. Thanks for joining us on this journey, and remember, in the world of science, there's always more to discover.